Hello, dear students. Let's learn the conversion of the linear programming problem or the mathematical problem into the dual form, and from that we will be solving into the graphical method. So first we need to see that whether this mathematical model in the canonical form or not. The first step is to check the canonical form. So this is the basic model which has just been derived from the problem, the real problem. From the real problem, we have just come up with this linear programming model or linear programming problem or the mathematical model we have. So we need to see whether it is in the canonical form or not. So how do we see it? In the maximization function, objective function, the inequalities must be less than. Inequality must be less than. So you see, both inequalities are already in the less than. So it is in the canonical form. Let's move ahead. Now, we know in the dual form, the objective function will be converted into the minimization one. Okay, and the values would be z equals to, we don't take it z anymore, we take it w instead z, so that it is different. Basically, duality is the another form of the linear programming model. So just to find the optimum solution in other way, so we try to convert the basic model into the dual form and solve it. So it is another way to check your solution. So you see, in the minimization, we have to convert the maximum into the minimum one. So it is converted. W is there instead of z. It is w instead of maximum function. It is minimum function. You see. So instead of 3, that is the coefficient of the objective function, we will be using the 8, the first value of the first objective function. The first constraint, the second constraint. So the first right hand side of the first constraint of the right hand side, that is 8. So we will write 8 over here, and x1 will be same, the variable will be same. Second is the right hand side, second constraint you see is this, and its right hand side is 5, plus 5. So we will write plus 5. The variable would be same. So this is the minimization function in the dual form. Now let's find out the constraint as well. So for the constraint, what you do, you just develop a matrix from the constraints coefficients. The first constraint coefficient is 2 and 3. Okay. Second constraint coefficient is 1 and 2. So we have to transpose it. So transposed would be, matrix would be, it convert. You have a choice, either you convert the row into column or column into row. Okay, so it is your choice. So let's take the row into column. That would be 2, 3, and 1, 2. Okay, so these are the new coefficients of the constraints of the dual function, duality. So the constraint would be, first coefficient of the constraint would be 2, and x1 variable would be same, plus 1. We don't write 1. x2. Okay, since it is the minimization function, so in the minimization we take the greater than sign instead of the less than sign, and instead of 8 we will be using the coefficient of the objective function, that is 3. Okay, so let me reiterate. 2 is the transposed matrix we found. Okay, and x is the variable, plus 1 is the next coefficient with the variable x2. Since it is a minimization, we have the objective of minimization, so the inequality would be greater instead of less than. With the right hand side, we have to change the right hand side from the objective function x1 coefficient, that is 3. x1 is the first coefficient, x1 is the first variable, and first variable coefficient is 3. So next, what would we do? The next is 3, and the variable we know is 1, x1, plus next is 2, next variable is 2, x2, and the inequality would be greater than n equals 2. And you see 5 is the next coefficient of objective function. So we will take the 5. Now we have come up with the minimization objective function, you see, and these are the constraints, the first constraint and the second constraint. So you see the first constraint is transformed from 2x1 plus 3x2 2x1 plus x2 में, and the inequality is changed from the less than to the greater than equals to, and the right hand side is changed from 8 to 3. And the second inequality you see from the x1 plus 2x2 is changed into 3x1 plus 2x2. The less than inequality is changed to greater than, and 5 is changed into 5. 5 is same. So you see, these are the new one. The objective function is quite changed from the 3x1 plus 5x2 to 8x1 plus 5x2. So this is, we are done with this. But remember to write, very importantly, the variable, we cannot use x1 and x2. We cannot use x1 and x2 as a variable in the dual form. So what we can do y, or you can choose any other variable, y. Y has to be used, y. Okay, so remember that. So at the end you write y1 comma y2 greater than equals to 0. So we are done with the dual form. Now, as the problem is, solve the problem by the graphical method. First we had to change in the dual form, then we have to go for the graphical method. So let's move ahead for the graphical method. So our minimization function is, let's rewrite again. Instead of z we write w. 8y1 plus 5y2